Greenland shark. This thing is the longest living vertebrate on the planet, and it's not even close. Scientists work that out by radiocarbon dating the lens of the shark's eye. That tissue gets laid down in layers over the animal's life, and basically never turns over again once it forms. Kind of like tree rings, except you can't see them from the outside. When researchers ran the dating on a batch of Greenland sharks caught as bycatch, the average came out somewhere between 272 and 512 years old. And the two biggest sharks in that particular study were estimated at around 335 and 392. None of that makes sense until you see how slowly this animal actually lives. It grows less than a centimeter a year. It doesn't hit sexual maturity until it's roughly 150 years old. Its top cruising speed is under 2 miles an hour, slower than most people walk, and it spends its whole life in freezing Arctic and North Atlantic water, where almost nothing happens fast anyway. But it's not just scavenging out there. Researchers have found seals in Greenland shark stomachs, which means this famously sluggish animal is somehow still catching prey that can swim circles around it, probably by ambushing them while they're resting or sleeping in the water, since outrunning anything clearly isn't an option. There's a real chance that somewhere in the Arctic right now, a Greenland shark is swimming around that was already alive before the United States existed as a country. Goblin shark. For more than 100 years after this species was first described in 1898, nobody actually knew how it caught food. It's got this long, flat, blade-like snout, and underneath it a jaw that just hangs loose and slack most of the time. It doesn't look like it's built for anything fast at all. Then in 2008, researchers finally caught one on video mid-feed, and it turned out goblin sharks had been hiding one of the fastest bite mechanisms of any fish in the ocean this entire time. They ended up calling it slingshot feeding. The shark swings its jaw down and back first to open an enormous gape, then fires the whole thing forward at speeds up to 3.1 meters per second, the fastest jaw protrusion ever recorded in a fish, launching out to nearly 10% of the shark's own body length in a fraction of a second. It doesn't need to be fast in open water, because the mouth does all the actual chasing, and that tracks with everything else about the animal. Soft, flabby body, small weak fins, basically no interest in swimming hard, living in deep water along continental slopes where actively hunting prey down just costs more energy than it's worth. Better to sit there and let the jaw do the work when something finally swims close enough. Megamouth shark. This is one of the last major shark discoveries of the entire 20th century, and it happened completely by accident. In November 1976, a U.S. Navy research vessel off Hawaii pulled up its sea anchor and found a 14.5-foot shark tangled in it that nobody on Earth had ever documented before. Different enough from anything on record that it eventually got handed its own entire taxonomic family, all to itself. It's a filter feeder, and there are only 3 shark species on the planet that make a living that way instead of hunting: megamouth, whale shark, and basking shark. But megamouth does it differently from both of the others. It's got this huge bulbous head and soft, almost rubbery-looking lips, and some researchers think the inside of its mouth might actually glow faintly to draw plankton and krill in close enough to filter out through the gills. Since that first accidental discovery in 1976, it's been recorded fewer than 100 times total, which makes it one of the rarest large animals on the planet that scientists have actually managed to document. Genuinely enormous, genuinely harmless, and we still don't know that much about it. Cookie cutter shark. Every other shark on this list earns its reputation partly through size. Cookie cutter shark is about the length of your forearm, and somehow still manages to leave bite marks on nuclear submarines. It's bioluminescent. Its belly glows a soft green-blue in the dark, mimicking the faint light filtering down from the surface above it, except for one narrow, unlit band around its throat that breaks up the glow just enough to look, from underneath, exactly like the silhouette of a small fish. Something bigger swims up expecting an easy meal, and instead of a snack, it gets a shark latched onto it. Thick, fleshy lips forming a suction seal, small hooked upper teeth anchoring in place, and then a rotating bite from the saw-edged lower jaw that carves out a clean, perfectly circular plug of flesh before the cookie cutter lets go and swims off with it. Whales carry those scars. Tuna carry them. Even great white sharks carry them. And the US Navy has genuinely documented cookie-cutter bites on the rubber sonar domes of submarines, the shark apparently mistaking a slow-moving multi-million-dollar vessel for the exact kind of large, sluggish target it usually goes after. Thresher shark. A thresher shark's tail makes up close to half its entire body length, and for a long time nobody could say for sure what that tail was actually for. Researchers had theories, but nobody had footage. Then a team finally got underwater video of pelagic threshers hunting sardines off the Philippines, and it turned out the tail wasn't just for swimming at all. It was a weapon. The shark pulls its pectoral fins in tight, which flips its whole body pitch forward and snaps that oversized tail through the water fast enough to stun or outright kill several fish in a single strike. Researchers think the impact might even be hard enough to knock dissolved gas out of the water and form actual bubbles from the force of it. Then the shark just eats the stunned fish, sometimes more than one at a time, out of a school it never had to individually chase down at all. It's genuinely one of the only hunting strategies in the ocean built entirely around using a fin as a club instead of a swimming tool. Hammerhead shark. The head is really the entire story with this one. That wide, flattened structure running side to side, called a cephalofoil, is packed edge to edge with electroreceptor organs, which means a hammerhead isn't just seeing its prey out there, it's picking up the faint electrical field every living thing gives off, just from having a beating heart and firing nerves. That sense turns out to be perfect for one very specific kind of hunting. Stingrays, buried completely under sand, invisible to normal eyesight from directly above. Hammerheads sweep that wide head back and forth across the seafloor, almost like a metal detector, until the electrical signal gives the buried ray away, then pin it down with the head itself, before delivering the actual bite. It's a hunting method built entirely around a sense most other sharks just don't have anywhere near as finely tuned. The head shape also happens to spread the eyes out to either end, which gives hammerheads close to a 360-degree vertical field of view and noticeably better depth perception than sharks whose eyes sit close together on a narrower skull. Whale shark. Whale shark is the largest fish in the ocean, full stop, regularly topping 40 feet, and it gets there eating almost nothing but plankton, small fish, and loose fish eggs, filtered out through its gills as it cruises slowly through the water with its mouth held open. Despite the size, it's genuinely harmless to people, calm enough that divers routinely swim right alongside one without it reacting to them at all. Growth is slow, and it takes decades to reach maturity, which is a big part of why so little was known about how it actually reproduces for so long. The only pregnant whale shark ever properly examined was carrying over 300 pups at different stages of development all at once, which told researchers the species doesn't lay external eggs the way plenty of other sharks do. It keeps them developing inside the body and releases live young over time instead. It also gathers seasonally at specific coastal locations where food happens to concentrate, and that's mostly how scientists study it at all, because finding one out in open ocean the rest of the year is basically down to luck. Great white shark. Great white probably doesn't need much of an introduction, and honestly that's part of the problem. Most of what people think they know about it comes from movies rather than actual biology. It's a real apex predator, capable of exceeding 20 feet and 2,000 pounds, using a mix of speed, size, and a testing bite to take down prey like seals and sea lions, frequently striking from directly below in a fast vertical ambush powerful enough to launch the shark partly or even fully out of the water. What gets talked about less is how much of its hunting is actually about caution instead of aggression. Great whites will often bite once, back off, and just wait for an injured animal to weaken before finishing it off, a strategy that keeps the shark from risking real injury against a large, struggling, potentially dangerous prey animal fighting for its life. They're also warm-blooded to a degree most fish simply aren't, able to hold parts of their body several degrees above the surrounding water temperature, which lets them hunt effectively in colder water that would leave most other sharks sluggish and slow to react. Bull shark. Bull shark can do something almost no other shark on Earth can manage: live comfortably in fresh water for extended periods. It's been documented far up the Mississippi River, living permanently in Nicaragua's freshwater lakes, and turning up in rivers across multiple continents, tolerating a massive swing in salinity thanks to specialized kidneys and a rectal gland that let it regulate salt balance whether it's sitting in open ocean or a muddy river hundreds of miles inland. That range puts it in contact with people a lot more than most sharks ever are, which is part of why it's considered one of the more dangerous species to humans, right alongside great whites and tiger sharks. It's also just a stocky, opportunistic predator by nature, thick-bodied, strong-jawed, willing to eat pretty much anything that fits in its mouth, from fish to smaller sharks to the occasional land mammal that ends up in the water. Pups get born in freshwater or brackish river systems specifically, because those nursery areas tend to have far fewer large predators around than the open ocean does, meaning bull sharks essentially grow up somewhere safer before ever making the trip out to the saltwater environment they'll spend most of their adult life in. Tiger shark. Tiger shark has earned itself a nickname most predators never get: the garbage can of the sea. Its stomach contents, pulled from decades of research, read like a list of things that have no business being inside an animal: license plates, tires, boat cushions, and in one well-documented case, an entire suit of armor. It's not picky, and honestly it doesn't need to be, because broad, heavily serrated teeth let it cut through almost anything, including sea turtle shells that most other predators simply can't get through at all. It's also one of the only sharks that regularly targets adult sea turtles, which puts it in a genuinely small category of predators actually capable of breaking into that kind of armor on purpose instead of by accident. Juveniles start smaller: fish, squid, crustaceans, and the diet broadens dramatically as they grow, eventually stretching to birds, other sharks, and marine mammals. Tiger sharks are also ovoviviparous, meaning the eggs hatch inside the mother rather than out in the water, and she gives birth to live pups, sometimes 30 to 80 of them in a single litter, one of the largest litter sizes of any shark on this entire list.